We're solving problem 10 from the 2023 AIME 2. Let n be the number of ways to place the integers 1 through 12 in the 12 cells of a 2x6 grid, so that for any two cells sharing a side, the difference between the numbers in those cells is not divisible by 3. One way to do this is shown below. Find the number of positive integer divisors of n. Now the first thing we can do for this problem is we can replace all these numbers with their remainders when divided by 3. So like think about mod 3, right? Then this problem would be much simpler. Now notice that there cannot be repeats of numbers in succession, as that's impossible. So we can just count the numberings when we basically just replace each number with its remainder when divided by 3. Then we count the number of ways this yields, and then we multiply. This is very important. Multiply by 4 factorial cubed. This is necessary for this process. So then we'll basically just be left with some pairs, and we'll be left with pairs of 0 and 1 in a column, 1 and 2 in a column, and 0 and 2 in a column. There will be in total, there will be 4 of the 0 and 1 and 0 and 2, however only 2 of the 1 and 2 in the columns. So we have that, and this yields 6 factorial over 2 factorial times 2 factorial times 2 factorial equals 90 ways to arrange the columns, right? But however, each column has more than one entry, so this number can be doubled to 180. So 180, and then multiply by this number we got right here, 4 factorial to the power of 3 is obviously a very, very large number. We want to find the number of positive integer divisors of n, and one way we can do this is prime factorize this number, and then we can do the trick with the powers. So this becomes 2 to the power of 11 times 3 to the power of 5 times 5 to the power of 1. The power trick is where the number of divisors of any number in its when we split it up into prime factors, it goes like this. So you have 11 as a power, right? 11 plus 1, and then multiply it by the next power plus 1. So there's 5 as a power, so you do 5 plus 1, and then you do 1 plus 1. So then we have the number of factors here. This is 12 times 6 times 2, which is 144. 144 factors is our answer.